Good morning, students. Today we are going to discuss about the lattice imperfections. So what is a crystal? Crystal is the regular arrangement of atoms at their lattice points. So any disturbances or any deviations in this crystal structure is called as a lattice imperfection. Crystal is the regular arrangement of atoms in a periodic manner. Any deviations, for example a missing of atom or ion at this lattice point is called as a imperfections. These imperfections are observed in especially in metals. What this affect? These imperfections will affect the metallic properties such as specific heat, and they will also affect the conductivity, obviously the resistivity and the capacitance, of the metals. These imperfections will affect the basic phenomena such as specific heat, conductivity and capacity of the metals. These are called lattice imperfections. There are two types of lattice imperfections called point imperfections, and second one is line imperfections. What is point imperfections? Point imperfection means this is a very smallest imperfection. The name itself indicates it is a point, a small imperfection or zero dimensional, that is zero-dimensional imperfection is called as a point imperfection. So this is arised due to the missing of atom at that lattice point or the missing of positive ion, negative ion at a particular lattice point. These are called the point imperfections. Point imperfections are small. They are involving a less number of, that is either one or two missing of atoms at their lattice points or the ions. Again, these point imperfections are categorized as Frankel defect, and second one is Schottky defect. Point imperfections are again categorized as Frankel defect and Schottky defect. So what is Frankel effect? So if you consider a lattice having the positive charges and negative charges, distributed over the crystal, the transfer of these lattice ions, they are also called as regular positive cations or anions from their regular sites to interstitial sites. For example, this positive ion may be transformed to this position. So this is its regular site. So by the application of some temperature or due to the surroundings, if the ion is transformed, then that type of effect is called as Frankel effect. So this is the movement of the positive ion and negative ion from its regular site to interstitial site by the surroundings. So this is a very simple defect. So next defect is Schottky defect. Schottky defect is observed in a metals for which the transfer of an cation and anion together, that is here only a motion of a single positive charge or negative charge will takes place in case of Frankel defect, whereas in Schottky defect equal number of positive charges or negative charges are vacating their position. So in order to balance the total system. So this is called as the Schottky defect. So imperfections are the regular arrangement of crystal may be disturbed due to some conditions. Any small deviations from its structure is called as imperfections. They are mainly observed in metals. They will affect the following phenomena. There are two types of imperfections called point imperfections, line imperfections. Point imperfections are very small and they are zero dimensional. So again, point defects are further categorized as Frankel defect or Schottky defect. So Frankel defect is observed when the transfer of positive ion or negative ion takes place from its regular lattice site. Schottky defect is observed the transfer of positive and negative ions from its regular vacancy sites. So here the compensation takes place. So that is, if two number of positive charges are traveling, along with that two negative ions will also starts moving from their regular sites. So this is regarding the point defect. Next, line imperfections are called single dimensional imperfections. They are observed in the row of system of arrangement of atoms. That is, if one atom is removed or in an array of atom, then that type of imperfections are called line imperfections. These are the fundamental imperfections that we have studied in a lattice. Next one is F centers. What are F centers? Here F means Faraday. Faraday is a German word. The meaning of Faraday. Hello students, this is one of the small topic called as order disorder transformation. Let us consider an alloy. Alloy is nothing but the mixture of atoms or the elements. If you consider the sodium chloride alloy, so which is the mixture of sodium plus ions and chlorine minus ion. So for example, consider AB alloy, which is having two different elements A and B. So by default, let these type of structures are A and these dotted lines are B. So at zero temperature, all these atoms A and B are regularly arranged. So this is the ordered arrangement of an alloy. If you increase the temperature of an alloy at a particular temperature called Curie temperature, the order of an alloy will be disturbed. So here all are regularly arranged. Here they are arranged but with different structure or disorderly manner. So in this unit lattice we have all A's and B, but here there are different. So this type of transformation from order to disorder is called as a order disorder transformation. So if you draw the graph between temperature versus order, with the increase of the temperature, this order nature of any alloy decreases at a particular temperature called Curie temperature. The total system is disordered. So this is the order disorder transformation of an alloy. Next, a small topic is F center. So what is F center? F means Faraday. So it is a German word. Meaning of this Faraday means color. So F centers or color centers are same. How these F centers are generated? How these color centers are generated? When a crystal is heated in presence of alkali vapor, these F centers are observed. When a crystal is heated in presence of alkali vapor, these F centers are observed. Especially these F centers are observed for the metals having more cations than anions. That is, if there are more number of positive charges and less number of negative charges in a metal, then in those type of metals we can observe this F centers. So if there are less number of negative ions, so all the positive charges are accumulated. So negative charges are less means there are some vacancies called as holes. Holes are created inside the metals having more number of positive ions and less number of negative ions. When this metal is subjected to a temperature in presence of alkali such as sodium, sodium is a positive ion. So this positive ion interacts, for example, this is a sodium chloride structure, that is, these are all sodium plus ions, chlorine minus ions. So sodium plus interacts with chlorine minus ions and they will form some pair. So this hole will attract the electron from these nearest neighboring atoms. So these electrons are captured by this hole. So by absorbing that electron, this hole will be colored. So if it is in presence of sodium vapor, this hole is appeared in yellow color. For a potassium chloride, the holes attracted by the electrons will generate a light in violet color. So this is a simple topic called F center. F centers are observed in a crystal when the crystal is heated in a alkali vapor, especially in a crystal having more number of positive ions and less number of negative ions. These F centers will be observed. So in sodium chloride we will observe the F centers in yellow color. In potassium chloride we will observe the F centers in violet color.